Hello students, welcome to yet another lecture on dynamic programming. And in this lecture, we will study about the coin change problem. So, do you remember the coin change problem? This is the same problem which we discussed using the greedy approach. That is finding the minimum number of coins to make up a value. Okay, so the same problem is given to us, but this time we will use dynamic programming instead of the greedy approach to solve this problem. So let us dive in and see how this problem can be solved using the dynamic programming. So the problem statement is same as the previous problem, that is finding the minimum number of coins using the greedy approach. So we have been given a value v. V is the amount which we have to make. For example, v is equal to 11. So we have to make a change for value equal to 11. Then we have infinite supply of all the valued coins. So this is set S, which contains all the denominations S1, S2 till Sm which we have. Okay, and we have infinite supply of these denominations. Okay, let us say S is equal to 1, 2 and 5. Okay, then if we want to make an amount equal to 11, then what are the options which are available to us? We can take all the 1 rupee coins, right, and make the value equal to 11, and this will require 11 number of coins, right? Or the second approach is we can use 1 plus 1 plus 1 plus 1, 9 coins and a 1 2 rupee coin. Okay, and in this case we will need only this will add up to 11, and we will now need 9 coins. Another approach can we can use 2 rupee coins, 5 coins and a 1 rupee coin. Okay, this will make up the value 11, and in this case we will need only 6 coins. Even better, we can use 2 5 rupee coins and a 1 rupee coin, and in this case we will need only 3 coins. So what is our purpose? Our purpose is to reduce the number of coins as much as possible. We want to use the minimum number of coins. That is, we want our solution to be this. This is the optimal solution, right? So now, how to solve this problem using the dynamic programming approach? So the dynamic programming approach, is applicable if the problem has a optimal substructure. That is, the original problem can be solved by solving the smaller subproblems. And with the help of an example, we will see that this coin change problem has an optimal substructure, right? And it can be solved using the greedy approach. So in order to understand how the dynamic programming approach works for coin change problem, let us take an example. And in this example, let us say the amount or value which we want to make is equal to 7, and the denominations which are available to us are 1, 2 and 5, and we have an infinite supply of these values. Okay, so what we will do in dynamic programming approach, we will create a matrix, right? So this is the matrix. In this matrix, this is the horizontal axis. Let us say these values are we have a variable j for these values. So j can be 0, 1, 2, 3, 4, 5 up to 7. Okay, and why up to 7? Because the amount which we want to make is equal to 7, right? And it means this horizontal axis stands for the amount. Okay, so we are dividing the total amount. The 7 is the total amount which we want to make, and we are dividing it into sub problems. That is, when amount is 0, when amount is 1, when amount is 2, when amount is 3, and so on. Okay, so we are breaking up the total amount into smaller amounts. Okay, and similarly on the vertical axis, let us say we have the variable I. Okay, and here also although we have 3 coins, okay, but we have 4 rows. The first row is 0, that is, it stands for no coin, when we do not have any coin. Then when we the next row means when we have the first coin, and in this case the value of the first coin is 1. Then this is for the second coin, the value of the second coin is 2. The last row is for the third coin and its value is 5. Okay, now before solving the sub-problems, let us see whether there are some base cases or boundary cases which we can solve trivially, which cannot be broken further into any more sub-problems. This is what we did in the case of Fibonacci numbers, right? In the case of Fibonacci numbers, the base case was when the Fibonacci number when the value for which you want to find the Fibonacci number is 0 or 1, right? So we were using a bottom up approach. So same kind of approach will be used here also, right? And in this case, you can see that there are two kinds of boundary cases. The first case is when you do not have any coins, no coins. This one, this row, no coins. When you do not have any coin and the amount which you want to make is greater than 0, then what will happen? In that case, we will fill all these amounts with value equal to infinity. Okay, so it means we need an infinite supply of coins. Okay, so this is the base case and these problems are already solved. Okay, so these all the cells represent here the sub problems. Okay, so out of all these sub problems, how many sub problems do we have actually? In this particular example, this is 4 into 8, right? These many sub problems are there. So we have already solved this sub problem, that is amount equal to 1 and you do not have any coin, amount is 2 and you do not have any coin, and so on till 7, amount is 7 and you do not have any coin, right? And the second kind of base case is when you have an infinite supply of coins but the amount you want to make is 0. Okay, so if you want to make 0 amount, you do not need any coin. Okay, so we can say it is 0, 0, 0, 0, right? So if you have no coin, still you do not need any coin to make 0. If you have a 1 rupee coin, you do not need it because the amount you want to make is 0. Similarly, if you have 2 rupee coin but you do not want to make any amount, so the coins required will be 0, right? So these are the boundary cases, right? So we have solved these cases. Now let us move to the other sub problems. Now these sub problems are dependent on the sub problems which we have solved previously, right? So these sub problems, right? These sub problems will help us to solve these subproblems, right? And there is a method for it. What is the method? For each subproblem, right? Let us take this subproblem. What is this subproblem? It is saying that you have to make amount equal to 1, and here you have coins, you have one coin and it is a 1 rupee coin. Okay, so this is a subproblem, and for this subproblem you have two choices. One is to include this coin. You can take a 1 rupee coin, or you can exclude this coin. You choose not to take this coin. Okay, so exclude I or include I. Okay, so what will happen if you decide to exclude I? Here I is 1. I am talking about this problem. Okay, so exclude I. If I decide to exclude the 1 rupee coin, and the amount I want to make is 1, right? So in that case, it is this statement which will be executed. So what is it saying? It is saying that dp I is, we are at this row and this column. So I is 1, that is you have the first coin and its value is 1. It is a 1 rupee coin. And J is the amount which you want to make. Okay, so dp11 means this problem, if you decide to exclude a 1 rupee coin, then it will be equal to dp, you are excluding this coin, right? So its solution will be the number of coins needed by you will be equal to the number of coins you needed in the previous step. So what is the previous step? That is I minus 1, when you used a previous coin, right? So I minus 1 is 0 when you used a no coin. Okay, and the amount was same, the amount was 1. Okay, so it means you are excluding this 1 rupee coin, so the number of coins you need to make an amount equal to 1 will be same as the number of coins you needed in the previous step, that is when you had a 0 coin. Okay, so when you had a 0 coin, you needed infinite supply of coins to make an amount 1. Okay, so this is one choice, and the second choice is you decide to include I, you decide to take this 1 rupee coin. Okay, and in that case what will happen? dp I 1 rupee coin and J, the amount is 1, is equal to 1. Why 1? Because now you are taking up this coin. Okay, so the total number of coins will be increased by 1. Okay, and plus dp I using the 1 rupee coin. Now you are using this coin. Okay, so you are adding 1 coin. Here you have added this coin, and after taking this coin, what is the amount left? The amount left will be J is 1 minus coins I minus 1. So I is 1, 1 minus 1. Okay, so what is this? Let us see. So coins is an array which stores the values of the coins you have. Okay, so you have 3 coins in this particular example, so it is an array starting from 0 till 2, and the value of 0th coin is 1, the value of first coin is 2, and the value of second coin is 5. Okay, so what are you doing? You want to make amount 1, okay, and you take a 1 rupee coin, okay. So the number of coins are increased by 1. And what is the amount left after taking this coin? After taking this coin, you have you are left with no amount, okay, you are left with 0 amount, okay. So it is saying that the number of coins after taking this coin, the number of coins you needed to make up the rest of the amount, okay. So it is dp I 1 minus coins I minus 1, okay. It means what is the value of the coin you are taking, okay. You are taking a 1 rupee coin, so its value will be found here, okay. So 1 rupee coin in this example, in this matrix, is stored at, this is location 0, this is location 1, 2 and 3. So it is stored at location 1, right? And in this array it is stored at location 0. That is why we are doing I minus 1. So we have to look at one location, one previous location in coins array in order to find the value, okay. So that is why I minus 1, 1 minus 1, coins 0, okay. So the value of this coin, the coin which is here at the first location, its value will be stored at 0th location in this coins array. And what is its value? Its value is 1. It means it is a 1 rupee coin, okay. So it is a 1 rupee coin and its value is 1. So 1 minus 1, okay. So it means the amount which we were trying to make was 1 and we took a 1 rupee coin. So the amount which is left is 0, okay. So D, I think it is not visible because my picture will be here, okay. So let me write everything here at some other location, okay. So dp 1 rupee coin and amount is also equal to 1 is equal to, we take up the 1 rupee coin, so 1 plus dp1, the amount minus the value of that coin which you are taking, okay. So it is 1 plus dp1, so its value is at location 0 and here we saw that its value is 1. So after taking this coin, the amount left is 0, okay. So amount left is 0. So what was the solution for this? Its solution was 1 plus row 1 and column 0. So it means you are trying to make an amount equal to 0. For making an amount equal to 0, you do not need any coin. So its answer is 0. So 1 plus 0, 1. So these are the two solutions which we found. One by excluding I, that is excluding 1 rupee coin, and the second by including 1 rupee coin, okay. And so out of these two choices, we will take the minimum, okay. So minimum means we want to minimize the number of coins. So whichever is minimum out of include I and exclude I, that we will take, okay. So minimum is 1. So we take 1, okay. So now you can see there is a DAG here, okay, directed acyclic graph, which is being created here, right. The solution to this subproblem depends on this subproblem and this subproblem, right. Now we have solved this subproblem. Now we can move to the next subproblem here, right. So here what are we trying to make? We are trying to make an amount equal to 2 and the coins which we are using here is 1 rupee coin. In this row, we are using only 1 rupee coins, right? So amount you are trying to make is 2, right? So again you have two choices, include 1 rupee coin or exclude 1 rupee coin. Okay, so if I exclude I, so here it is I, DPIJ. Now J is 2. The amount which I try to make is 2. And I exclude this coin. So the solution will be same as taking the 0th coin. Okay, so it will be coming from the upper cell, right? If I decide to include I, then what will be happening? 1 rupee coin and amount is 2. Now I am including, so I add a 1 here. And what is the rest of the amount? The rest of the amount is using the 1 rupee coin. Amount is 2 and coins j minus, what is here? Coins I minus 1. So I will look up for the value of ith coin. It will be here. Okay, so it is 1. So it is DP 1 1. Okay, so after picking this 1 rupee coin, the total amount will be reduced by 1. So amount I am trying to make is 2 rupees, and after picking 1 rupee coin I am left with 1 rupee. Okay, so this sub problem is already solved. Okay, so what is the solution when you have a 1 rupee coin and the amount you are trying to make is 1? This, which we solved in the previous iteration. Okay, so it is 1. So the total number of coins now I need is 2. So I will choose the minimum of these, infinite number of coins or 2 coins. So 2 coins is better, right? So we have solved this also. Again a DAG is being created here. Now let us move to amount 3. Okay, so using 1 rupee coins, we are trying to make amount equal to 3. Again, we can include 1 rupee coin or exclude 1 rupee coin. If I exclude 1 rupee coin, then the amount 3, its solution will be without using 1 rupee coin, and it will come from the upper cell, that is infinity. When you used no coin, the answer when you used no coin. And when you try to include this, now amount is 3. Now include a coin, so 1. And using 1 rupee coins, you are trying to make amount equal to 3. And what is the amount left? Amount left will be 2, right? You choose a 1 rupee coin. The total amount is 3. So you choose a 1 rupee coin. The amount which is left is 2. Okay. So you are left with 2. So this is already solved. We do not need to solve it. What is the solution to this? When you use a 1 rupee coin and try to make amount equal to 2. That is DP1, 2. This one. Okay, right? And here the coins we needed was 2. So 1 plus 2, now total number of coins are 3. And out of infinity and 3, the minimum is 3. So we will choose it. Okay. Similarly, the same thing will happen for this sub problem. So if you exclude 1 rupee coin, then you will need infinite number of coins. If you include it, then you will need 1 coin plus the number of coins you needed for making amount equal to 3, which will come from here. So total 4 coins will be required by you, and out of infinity and 4 you will pick 4. Similarly, here the answer will be 5, here the answer will be 6, and here the answer will be 7. Okay. So now we have solved this row, right? Using the 1 rupee coin, the minimum amount, the minimum number of coins we needed to make all these values. Okay, so now let us move to the next row. Okay, so now you also have a 2 rupee coin. Okay, so when you have a 2 rupee coin and the amount you want to make is 1, can you make an amount equal to 1 using a 2 rupee coin? No, you cannot make it, right? So you have to exclude it. The only choice you are left with, do not take a 2 rupee coin. Okay, so in that case the solution will be simply copied from the upper cell. That is the solution using 1 rupee coin. Okay, so now let us move to this. Let me remove these boxes. Okay, okay, so now we are here at this cell. Here we want to make amount. Let me delete some extra things here so that we can focus on this. Okay, so here amount is 2, right? You can see here the amount which we are trying to make is 2, and now you have 0, 1 and 2 rupee coins. 0 is that is, it means just that you do not have any coin, and you have a 1 rupee coin and you have a 2 rupee coin. Okay, so now you can use 2 rupee coin or you can not use 2 rupee coin. Okay, exclude 2 or include 2. Okay, so now let us see what happens when I exclude 2. I do not pick 2. Okay, so when I do not take 2, so here I is 2. It is dpi, that is 2, and j. J is the amount which I am trying to make. So using a 2 rupee coin, I want to make a amount equal to 2, but I decide to exclude it. Okay, so what will be the solution then? Solution will be what was the solution using the lower denomination coins, that is 0 coin or 1 rupee coin. Okay, so that is why it is written it is equal to dpi minus 1, that is 1 comma j. It means what was the minimum number of coins you needed when you had only a 1 rupee coin. Okay, so it is dp 1 comma 2, that is this thing 2. Okay, so when you do not use 2 rupee coin, you will use 1 rupee coin, and to make an amount equal to 2, you will need 2 1 rupee coins, right? And the second choice is you choose to include 2. Okay, so now let me erase these things. Okay, so yeah, 2 2. Okay, coins 2 rupee coin and amount 2. So you choose this coin. So 1 coin is added to the total number of coins. And when you add this 2 rupee coin, what is the amount left? The amount left will be j, this will be 2, okay? J minus coins, the value of 2 rupee coin. That is 2 minus 1. It will be available in coins at location 2 minus 1, that is at location 1. Okay, so 1 plus j, j here is amount, that is 2, and the amount of the value of 2 rupee coin is also 2. So when you choose a 2 rupee coin and the amount you want to make is also 2, the amount left is 0. Okay, so dp to 0. Okay, so it means you will need additional coins equal to the number of coins you needed when you wanted to make the amount equal to 0. Okay, so for amount equal to 0 you do not need any coin, so totally you need only one coin. Okay, so using a 2 rupee coin you will need only one coin to make the amount equal to 2, and out of these two solutions, in exclude 2 or include 2, you will pick 2, you will include 2, so final answer will be 1, right? So this is solved now, and now let us move to this sub problem. Okay, so here again, now we want to make amount equal to 3. Okay, and here you are using 2 rupee coin. You include 2 rupee coin or exclude 2 rupee coin. Okay, so when you exclude 2 rupee coin, the solution will be the solution using 1 rupee coins. Okay, so it was 3, and when you include this 2 rupee coin, then amount is 3, then here it will be 3. Okay, by picking 2 rupee coin, the amount you want to make is 3, you pick a 2 rupee coin, so the amount left is 1. Okay, so amount left is 1. And what was the solution for this? DP21, that is using 2 rupee coin and amount is 1. Okay, so using a 2 rupee coin we cannot make amount equal to 1, right, which we saw here also. This is the problem which we are talking about. Using a 2 rupee coin, the amount which we are trying to make is 1, and in that case we just copied the solution from the upper cell, that is we solved it using 1 rupee coins only. Okay, and using 1 rupee coins we needed only one coin. Okay, so here it will be 1, that is we need a 2 rupee coin and a 1 rupee coin. Total number of coins will be 2. Okay, so these are the two solutions, 3, 2. 3 means you are using 3 1 rupee coins, you are not including a 2 rupee coin, and the second is you are using a 2 rupee coin and a 1 rupee coin. Okay, so you are using 2 coins, and out of these the minimum is 2. Okay, right, and similarly we will go here. Now here the amount which we are trying to make is 4. Okay, so for 4, when we use 4 here and we exclude this 2 rupee coin, the solution will be just coming from the upper cell, right? And when you include this 4, then the solution will be, oh sorry, this is 2 and this is 2, 2 2. Okay, so we are picking a 2 rupee coin, so we are adding one coin here, and the amount which is left is 2. Okay, so what is the solution for this? It is DP2 comma 2, that is you need one coin, right? It is coming from here. So in total you need 2 coins. Okay, 2 2 rupee coins. Okay, so out of 4 and 2 you will pick 2 because it is smaller. Okay, similarly for 5 rupee coins you can exclude 2, in that case you will need 5 coins, or you can include 2. When you include 2, you pick a 5 rupee coin, you add 1 coin to the solution, and the solution or the amount which is left is 5 minus 2, that is 3, and the solution for this is 2 comma 3, that is you need 3 coins. Okay, 2 comma 3 you need 2 coins, it is coming from here. Okay, so total you need 3 coins. Okay, 5 comma 3, the maximum is minimum is 3, right? Similarly, 6. For 6, you can use 6 1 rupee coins, or you can include a 2 rupee coin, and in that case you add 1 coin to the solution and the rest of the amount is 4. Okay, for making a 4 you need 2 coins. Okay, so total you need 3 coins, and out of 6 and 3, 3 is the best, right? Similarly, we move here. If we do not include 2 rupee coin, we will need 7 1 rupee coins, and if we include a 2 rupee coin, then we add 1 coin to the solution and the amount which is left is 5. And for solving this problem of 5 amount equal to 5, we will need 3 coins. Okay, 3 coins. So the total number of coins you need are 4. And out of 7 and 4, 4 is minimum, right? Okay, so this was using the 2 rupee coins. Now let us move to the last row. Now you also have a 5 rupee coin. Okay, so when you have a 5 rupee coin and the amount you are trying to make is 1, can you include a 5 rupee coin? No, you have to exclude it, and in that case you will just copy the upper cell. For 2 also, you cannot make an amount equal to 2 using a 5 rupee coin, so we will copy the upper cell. For 3 also, we will copy the upper cell. For 4 also, we will copy the upper cell. Now for 5, we can include 5 or we can exclude 5. Okay. So now we are talking about 5, and the value which we are making is also 5. When we try to exclude a 5 rupee coin, then the solution will be just a copy of the upper cell. Okay, so here I am writing 5. 5 is the value of the coin. The column number or the cell number is, the row number is 3. Okay, so it is, when you exclude this third coin, then you will just copy the solution from upper cell. Okay, the solution is 3 here. You need 3 coins. If you exclude a 5 rupee coin, you will need 3 coins to make an amount equal to 5. Okay, but when you decide to include this coin, the third coin whose amount is 5, and the amount you are trying to make is also 5, and you include this, so you add a 1 to the solution, and by including this 5 rupee coin, the amount which is left is, we can get the value of the third coin from the coins array at location 2. Okay, so it is 3 minus 1. Okay, and 3 minus 1 is 2, location 2, and at location 2 the value is 5. So the value of the third coin is 5. It is a 5 rupee coin. Okay, and the amount left after picking the third coin, 5 rupee coin, is 0. Okay, and it will be 3 here, 3 here. Okay, so for making an amount equal to 0, do you need any coin? No. So it will be 1 plus 0, 1. So you need only 1 coin. Okay, and out of 3 and 1, the minimum is 1. So we will keep this. Okay, and then for making an amount equal to 6, you can include this coin or exclude this coin. When you exclude a 5 rupee coin, then you will copy the solution from the upper cell, that is 3. Okay, and when you include this coin, amount you are making is 6. So after picking a 5 rupee coin, the value which is left is 1. Okay, so the amount 1 for making an amount equal to 1, you will need 1 coin. Okay, and the total coins you need are 2. So 3 comma 2, and out of these minimum is 2. Okay, so to make an amount equal to 6, you need 2 coins, a 5 rupee coin and a 1 rupee coin, right? And lastly we reach here, which will give us the final solution, that is the solution to make an amount equal to 7 using the minimum number of coins. So here also you can include the 5 rupee coin or exclude the 5 rupee coin. When you exclude this 5 rupee coin, then you will simply copy the solution from the upper cell, that is you will need 4 coins. Okay, and when you include this 5 rupee coin, then after including, you will be left with an amount equal to 2. And for making an amount equal to 2, you will need a 1 coin. That will be 2 rupee coin. Okay, so the total number of coins you need are 2. Okay, so 4 comma 2, and out of 4 and 2, 2 is minimum. So this is the final solution, that is to make an amount equal to 7, we need 2 coins, a 5 rupee coin and a 2 rupee coin, right? So this is how we can solve this coin change problem using the dynamic programming, right? And here is the algorithm, right? So we are given this array coins, right, which is storing the values of the coins. So as in the previous example, the first coin had value 1, the second had value 2, and the third had value 5. Okay, and n is equal to coins dot size. So because we need to create an array of n plus 1 into amount plus 1, right? So we find how many coins are there. So the number of rows in your array dp is equal to the number of coins plus 1. Plus 1 because we also include a row when we do not have any coin, for 0 coin, right? And the number of columns are equal to the amount which we are trying to make plus 1, right? And then there are two loops, I loop and j loop. I loop is iterating over the rows and j loop is iterating over the columns. Okay, so the outer loop is I loop, means we are solving it row wise. For first we are solving for a particular coin for all the amounts, then we are going to the next coin for all the amounts, then we are going to the next coin for all the amounts, and so on, right? And these are the base cases. If j is 1, that is j is 0, the amount which you are trying to make is 0, in that case you do not need to solve any other further subproblems. You can just set that column equal to 0. Okay, sorry. And this is another base case where I is 0. Sorry. So I is 0 means you do not have any coin, and when you do not have any coin, then you will fill all the cells in that particular row equal to infinity, right? Else if coins I minus 1 is greater than 0, if your coins this is the case when the amount which you are making, j is the amount, okay, and coins I minus j is the coin which you are picking, and coin I minus j is the value of that coin. Okay, so suppose you are picking the first coin. Okay, so coins are starting from 0. So 0th coin, first coin. So if you are picking the first coin, right, and the amount which you are trying to make is smaller, can you make that amount with the first coin? No, you cannot make that amount. Okay, in that case you will simply copy the solution from the upper cell. So dpi j is equal to dpi minus 1 j, right, just as we did here. Here I is 3, okay, and its value in this table is 5. So when the amount is smaller than this value, we will just copy the values from the upper cell. Okay, so these were the values which we copied from the upper cell. Okay, and otherwise we will apply the dynamic programming strategy. So dpij is minimum of this thing and this thing. This thing means you are including that particular coin, so you add one coin to your solution plus the amount, the solution for the amount which is left. Okay, and this is when you exclude this particular coin. In that case you will just copy the solution from the upper cell. Okay, so this is how these two loops will work, and at the end we will return the final solution, and final solution will be at the last cell. Okay, and the last cell will be equal to its row will be equal to n, where n is the number of coins, and the column will be equal to amount, the final amount which we are making. Okay, so it will return this value. Okay, so depending upon if this value is greater than infinity, it means we were not able to solve it using the given number of coins. In that case we will simply return minus 1. Okay, otherwise we will return the solution, right? So this is the algorithm, and this is a pretty simple algorithm, which is having two loops. Okay, I loop and j loop. So if we try to analyze this algorithm, then this I loop is running n times. Okay, where n is the number of coins, and this j loop is running amount number of times. Okay, so the total complexity is number of coins multiplied by the amount. Okay, so in other words we can say the complexity is polynomial n square, or not n square, because amount can be any other value, so it is just a polynomial. Okay, n multiplied by your amount, right? So this is all about this dynamic programming approach to solving the coin change problem. Thank you.